Happy Friday, guys. So anyways, I was looking at what you guys were struggling with last night, and perfect squares came up. So for those of you that haven't tried perfect squares, it is a little tough, but you can do it. Now, what I'm going to do differently is I've been teaching pretty much all year the most popular way of factoring, which is using the X method, okay? I'm now going to show you how I do it with guess and check. So, let's get going. So, if you look at the first expression, the first thing that makes it difficult, if you look at it, is the fact that the numbers are all pretty big. And if you look carefully, guys, at 3, 30, and 75, I hope you realize, hey, you know what? I can divide by 3. So let's divide by 3. Let's do a GCF, greatest common factor of 3 here. And so I know x squared, for example, times 3 is 3x squared. That's done. I know that 10x times the 3 is 30x. That term is done. I know that 25 times the 3 GCF would give me 75. So now I officially gotten what I started with factored by 3. Now, if you look at what I have left over in the parentheses, now, actually, you could use the X method. And since the numbers are small, we could go ahead and do that. But here's what I propose to you. Hopefully you realize you're going to do parentheses. Can't you take x squared and just simply do x times x? The 25, the most common way is 5 times 5. And notice if I check the inner loop here, isn't 5 times x 5x? Now I'm going to check the outer loop. 5 times x is 5x again. I can get a 10x if I do 5 plus 5. So I know I'm going to do plus there, plus there. This is what you type in there, and you'll get it right. So what are you learning, hopefully, is that on these bigger number problems, guys, you got to look for the GCF first. You can't always GCF, but when you can, you got GCF to make the number smaller so you can do your factoring easier. All right, let's try another one. Look how big these numbers are. Now, guys, I'm thinking, you want to know something? I don't think they have any numbers in common. For example, this is even, but that's odd. I can't divide by 2 or any multiple of 2. This one I can divide by 3, but I can't divide that by 3. So you know what? There is no GCF on this one. Now, here's why I bring up my way, guys. If you do it the X method way, you have to do 64 times 81. My God, that's such a huge number. How are you going to break down 64 times 81? Right? Pretty impossible if you ask me, even with a calculator. So, here's what I propose. Why don't we guess and check it? I know I have 2 parentheses. Let me do it down here since I have actually a white screen, so it stands out even better. And I know 64x squared's got to be 8x times 8x, right? And 81, isn't that normally 9 times 9, 81? Now, here's what we do now. It may or may not be right, but we got to check. I'm going to check my inner loop. 9 times 8 is 72x. Now let's check the outer loop. 9 times 8x, 72x again. Can I get a 144x? 72 plus 72 is 144. Now, be careful of your negative right there, that minus. I need them both to be negative to get negative 144x. So that's why I'm going to do minus here and minus there. This, guys, if you type in right in there, you will get it right. Okay, let's try another one. Now, guys, if you look at this one, this has a 3. This also can divide by 3, right? 3 times 8 is 24. And 48 is 3 times 16. Okay? So what I'm going to do is a GCF of 3. Now, it's kind of backwards. So why don't we, first of all, put this in front and the constant number in back where they belong. So here's what we're going to factor is 3x squared minus 24x, okay, plus 48. Now let's do a GCF of 3 first. Does everyone agree? X squared times 3 is 3x squared. Minus 8x times 3 is minus 24x. Watch your signs. 48 is 16 times 3. Look how much easier this is, guys. So I know in my parentheses, I'm going to put in a 3, parentheses, parentheses. The x squared is x times x. 16, let's do 4 times 4. How do we get a minus 8? Well, the inner loop is 4x. The outer loop is 4x. How do we get a minus 8x? We make them both negative. Okay? So if you type that in, it should work. Now, because they had the numbers backwards, though, what I'm worried about is Khan Academy may be a little bit finicky with the answer. And that's what you have to get used to with these darn computers is they have a set of answers that they check on. And even though you may have the right answer, if it doesn't match what they're looking for on the computer, they're going to mark it wrong. But this for sure would work. Couldn't I just flip over 4 minus x, 4 minus x like that? These are really the same answer, guys. And this one really should work if you do it. If not, then the computer's actually wrong. Okay, let's try one more at least. This one here, you know what? It's backwards. Let's just do it backwards. Guys, if you look at the numbers, this, for example, is divided by 2, by 10, by 5. 49 doesn't play with those numbers, right? I can't divide 49 by 2, 5, or 10. Guess what? I can't do a GCF. So here's what I'm going to do instead. I'm going to set up my parentheses. What's normally 100? 10 times 10. What's normally 49x squared? 7x times 7x. Let's check our inner and outer loops. 7x times 10 is 70x. 7x times 10 on the outer loop is 70x again. Can I get a minus 140? Watch your signs. Yes, if I make them both negative, right? So I'm going to make these both minus. This is the correct factored form, guys, of what we started with. So this is my way of factoring, guys, where I just guess the combination of numbers. If it doesn't work, guys, then I try a different set of factors. And I'll be doing this with you just to make sure you get a good handle on it. Okay, let's see if there's another one. Nope, that's it. I got 4 out of 4 right. So, guys, hopefully this video on perfect squares helps you out. The important thing is give it a try. And also, guys, when you get stuck on something, skip around in Khan Academy a little bit. Come back to it later. Don't beat yourself over the head over and over again struggling with the same thing. Unless you feel like you're starting to learn it little by little. Then stick with it. All right? I'll see you around.